Is about the momentum, conservation, and impulse, page 1 of the study guide. Okay, so question 1, what is momentum? Okay, so basically momentum, remember we use this equation of momentum equals mass times velocity. That's kind of the main equation that we're going to use. But basically it's the amount of motion, so it's the amount of motion something has. Okay, what's the conservation of momentum? Basically what you need to know about that is that the momentum before a reaction is equal to the momentum after a collision. Okay, so that they are equal. Okay, so what is impulse? Okay, so impulse is equal to force times time. All right? And so another way of looking at it is you can say that impulse is also equal to the change in momentum. So basically you could write the equation, so you could say that the force times time is equal to whatever momentum was equal to, but it's a change in momentum, mass times velocity. And if you can look at it that way. But basically that's kind of if you apply a force to an object over a period of time, it gives it an impulse. All right, so we're going to do a little math here. So one thing that you will get on the equation is you will get this triangle right here. And on the triangle we have momentum, and we have mass, and we have velocity. So if you want to solve for mass, you just cover up the one that you're looking for. So mass is equal to the momentum over velocity. If you're trying to find velocity, you say velocity equals, you cover up velocity. Well, velocity equals momentum over mass. Okay, you will have to do that on the test that we have coming up the next day. And I think mostly you'll have to probably use this equation here. You could use that one. But anyway, all right, change the impulse momentum formula so you're solving for force. Now, I believe you won't have to do this on the test. I believe that the force equation is given to you. But the way I look at it is everything in this equation, force times time equals mass times velocity. Well, everything's on the top, the numerator. If you want to get force by itself, you have to move time to the other side. Well, whenever anything's all multiplied together, everything moves diagonally. So the time would go down there. So basically, you would have force equals mass times velocity over time. Okay, review question. Short answer. Which has more momentum? A bowling ball sitting at the edge of a table. Remember that momentum equals mass times velocity. Well, if it's just sitting there and it's not moving, a bowling ball's velocity equals 0. So anything times 0 is 0. So the bowling ball has 0 momentum. A ping pong ball is moving. And because it's moving, a ping pong ball does have a mass and a velocity if it's moving. So the right answer is the ping pong ball. Which has more momentum, a 10,000 kilogram train moving at 4 or a car, a 1,000 kilogram plane moving at 40? So we could just do the math here. We could take 10,000 kilograms times 4 meters per second. That's going to equal 40,000 kilograms meters per second. And if we do the plane is 1,000 kilograms times 40 meters per second. That also equals 40,000 kilograms meters per second. So they have the same momentum. What do you have to do in a momentum problem when one velocity is going to the right and the other velocity is going to the left? Well, the velocity to the right, we're going to assume that it's in the positive direction, and the velocity going to the left, we're going to assume is the negative direction. So if you're trying to do a problem with one momentum if your velocity, so if you do a P equals mv and it's going to the right, your momentum is going to be a positive number. If it's going to the left, when you do a P equals mv, because your velocity is negative, your P will be a negative number. Okay, explain a situation where an impulse over a short time is better than over a long time. Okay, so like a thing might be like, let's say in karate, you're trying to break a board, or like if you were boxing and you wanted to punch somebody in the face, you know, which is not nice, but I guess that's what they do in boxing. You want to hit them, and I guess if you didn't have boxing gloves on, if you had like a bare knuckle fighting, that would hurt a lot more because the time is shorter. But, you know, like that's kind of the way it goes, I guess. But if you're trying to break a board and you want to have an impulse over a short amount of time, because remember this equation right here, so force equals mass times velocity over time. If you make time short, if you make time very short, the force is larger. The force is larger. Okay, explain the reverse. Okay, when you want an impulse, well, you can have like an airbag in a car, and so like the force, like let's say you hit the airbag, if the time is longer, if time is longer, force is smaller. So like if you hit your face on an airbag, it doesn't hurt as much as you do if you hit it on a hard dash, I guess. All right, that's it for the first page.